6.5 circle and triangles. First of all, I'd like to remind you about the theorem, circle theorems. Uh, this is 90 degrees angle subtended at circumference from the diameter is 90 degrees. If I revise this one bit, we have a circle theorem. In this theorem, it says that angle is subtended by arc. This is the arc. So those are the angles. So angle is subtended by arc in the circumference. This is the circumference. Is half of the arcs, the angle subtended by arc at center. In other way, if this is A, this is 2A. The angle at the center of the circle subtended by an arc, in other way, the angle at the center of the subtended by an arc is twice the size of the angle at the circumference. So twice the size. This is A, this is 2A. Now I am expanding this arc. I am moving this arc. I am making more bigger. Then this is the line. Then I am making a bit bigger. This is the arc now. Likewise, those two lines, when those two radius in a one line through the center, like this. Now it will become like this. Now half is a semicircle. So this is the arc part. And then these two radius in a one line and become a diameter. Then we know this is going to be 180 because angle in a line add up to 180. Then if this is 2A, this has to be half of it. If this is 180, this has to be 90 degrees. So this is the idea behind it. So angle subtended by a diameter, angle subtended by a diameter at the circumference of circle is a right angle. It means 90 degrees. Now, how we are going to use, how are we going to use this knowledge for this chapter? Assume that you have 3 points. Assume that we have 3 points. This is the first thing. Second thing, these 3 points on a circle. That is the second thing. On a circle. Third thing, these two lines make a 90 degrees. That is the third thing. Make a 90 degrees. Then fourth one, conclusion. What is the conclusion? I write ABC. Conclusion is AB is a diameter. AB is a diameter. That's the conclusion. Or the second data. You have 3 points. That is the first thing. Should have 3 points in. And these 3 points on the circumference of a circle. That is the second thing. And this line, when you merge third one, it's become a diameter. Then what is the conclusion? Then when you merge those two lines, ACB angle is 90 degrees. Now you want to show that AB is a diameter. Then what you should do? You will get the gradient of this one, MAC, and you get the gradient of CB, and you multiply those two together and show this is -1. If you do this one, then AB become a diameter. This is one type of sum. The other one is you want to show this is 90 degrees. We can show it straight away perpendicular the same way. Instead of that, you want to show this is 90 degrees. Then you want to tell this is a triangle and the dots are on the circumference, points are on the circumference. And when you multiply, and what you need to show? You want to show that AB is a diameter. You find this distance. Okay, distance is 10 from the circle theorem. Not the circle theorem, from the circle equation, you will get this is 10 square. Then you know this R equal 10. And this AB distance also 10, R also 10, AB also 10, then R equal AB. Hence AB become a diameter. Hence what you could do, this ACB is 90 degrees. That's all basically inside the next few sums. The next one is, if this is a chord, let's say AB, and perpendicular bisector. So perpendicular bisector means line or dot, okay, a line going through middle, but it has to be 90 degrees, not this one. And we know that this is going through center. And then how many we do 1000 chords, still it is going through the perpendicular bisector, going through the this is the chord CD, and this is perpendicular bisector. So that one also going through center. Now when you forgot about this center scenario, there's a line here and this is another line. What will happen? This line intersect. When you look at this intersection point and when you see the center, they are going to be the same. This is a line and this is also a line. The intersection point of the line and the center of the circle are same. Perpendicular bisectors intersect at the center of the circle. In other way, you can tell that if you got another bisector from here, that that is also going through the center. This is 90 degrees. If you take another one from here, that is also going through center. How do we show that perpendicular bisector go through the center? So first of all, two perpendicular lines meet here. So intersection point. We find the intersection point of those two lines. And from the equation of the circle, we will get the center and we will tell those two are same. That's how the sums usually is fixed. Perpendicular bisector intersect at the center of the circle. Bisectors.